Hello, my name is Andrew Lenart, and this is my third lab in Physics 2211. So the goal of this lab is that we're each given the path of a star around a black hole, and we must analyze the movement and FNet parallel and perpendicular at each time step. And we must estimate an unknown mass for the black hole. We use GlowScript to calculate the forces at each time step delta t, and use the position data to derive the velocity, forces, etc. And I also created a visual model in GlowScript as well, which displays the data in a visual manner and uses the momentum principle, gravitational force equation, and the breakup of dp over dt in parallel and perpendicular parts. According to the data, the mass of the planet was around 1.31 times 10 to the 34th kilograms. As you can see here, here's a video of the moving star around the black hole and the different components of the force. So we see that Fnet is equal to dp over dt, and if you break it up, you can break it up into parallel and perpendicular components. So parallel component is the change in magnitude of momentum over change in time times p hat, and this is equal to Fnet parallel. As you can see here, first the orange is the Fnet, Fnet perpendicular is the cyan, and Fnet parallel is in the pink. And dp over dt perpendicular is the magnitude of momentum times the change in the unit vector over change in time. And that can be seen as cyan. And then we also have the force of gravity equation, which is shown here. But we know that Fg mag is the only force in the system, so we can say that Fnet is equal to force of gravity and the magnitude of it. And in this equation, the black hole, the mass of the black hole is the only unknown we have, so we can use the formula to solve for the mass of the black hole, how we will derive the mass of it. Now the code. So first we have to calculate velocities, then calculate net force, and then calculate F parallel. So as you can see here, it takes the position at the current time step and subtracts it with the position of the time step before, and divides it by delta t to get you the change in velocity. Then calculating net force, I take the P initial and P final, and we can get them to we can estimate that to be change in momentum. And because we approximate delta P to be change in momentum because delta t is very small. So Fnet is equal to delta p over delta t, the momentum principle. And as you can see here, the code calculates for that. dp over dt is equal to delta p delta t. Then Fnet parallel, we use to use the definition of Fnet parallel from above, and that p hat is equal to p initial divided by magnitude of p initial, and takes the change in magnitudes of the velocity, and uses the two values to get Fnet parallel. As you can see here, it calculates p hat, it takes the magnitude of momentum, and then dp over dt perpendicular parallel is the change in magnitude of momentum times p hat. Now calculating Fnet perpendicular uses the definition from before and takes the magnitude of velocity and multiplies it by the change in the initial and final unit vectors. And we estimate that to be d unit vector over dt, as dt is small. And yeah. And calculating the mass of the planet. So we calculate the position vector, and then we rearrange the force of gravity equation to solve for the mass of the black hole, which we will get in the code. As you can see here, this is the force of gravity equation, and we rearrange it to solve for mass of the black hole. Now conclusions. We found the mass of the black hole to be around 1.31 times 10 to the 34th kilograms. It makes sense if we plug it back into the F gravity equation. As expected, the Fnet always points to the black hole, parallel is parallel to motion, and perpendicular is 90 degrees to the motion. If we rearrange the parallel and perpendicular force into components, we find that Fnet is equal to Fnet parallel plus Fnet perpendicular. Possible sources of error, virtually none due to it being fully code, but selecting a smaller dt would give probably more accurate data. Final questions. What does parallel and perpendicular mean? So if we split the net force into parallel and perpendicular, we find out that the parallel speeds or slows down the object, and the perpendicular changes its direction. Now, what about a new black hole? So if we were to put a new black hole with a different mass, it would give us a different dp over dt, and therefore a different Fnet. And all the other variables will stay the same, therefore we can determine the new mass of the black hole. So by putting a more massive or less massive black hole, the net force would change due to the force of gravity equation. Thank you very much for listening to my lab, and yeah.